Every model we've seen learned something: weights, a line, a boundary. Our next algorithm learns nothing at all. It doesn't fit anything. It just remembers every example it's ever seen and answers new questions by looking at what's nearby. It's the simplest idea in machine learning: k nearest neighbors. Here's the whole philosophy. Instead of compressing the data into a formula, KNN keeps all of it. When a new point arrives, it asks a simple question: which stored examples does this most resemble? Similar things, it assumes, have similar answers. No equations, no training loop, just memory and a notion of close. To classify a new point, find its k closest neighbors and let them vote. If k is 5 and 4 of the 5 nearest points are cat, the new point is labeled cat. That's it. The crowd nearby decides. The k is the number of neighbors you ask, a choice that completely changes the model's behavior. KNN is what we call a lazy learner. Training does almost nothing. It just files the data away. All the real work is postponed to prediction time when it scans for neighbors. That's the opposite of a neural network, which trains for hours but then predicts instantly. KNN flips it: instant training, slow predictions. The whole method rests on a measure of distance. The usual choice is Euclidean distance, the straight line gap between 2 points, the same Pythagoras you learned in school, just in many dimensions. Other distances exist for other kinds of data, but the principle never changes: closeness equals similarity. The choice of k is everything. Set k to 1 and every point listens only to its single nearest neighbor. The boundary becomes jagged and noisy, overfitting to every quirk. Set k very large and it averages over half the dataset. The boundary goes smooth but blurs real distinctions, underfitting. The sweet spot is somewhere in between. Bias and variance again. Notice what KNN can do that logistic regression couldn't. Its decision boundary is not a straight line. It bends and curves freely, wrapping around whatever shape the data takes. With no equation forcing it straight, KNN draws boundaries as complicated as the data demands. That flexibility is its real strength. KNN isn't only for categories. To predict a number, just average the values of the k nearest neighbors instead of voting. Estimating a house price? Find the 5 most similar houses and average what they sold for. Same idea. Look around and let the neighborhood answer. KNN's appeal is its honesty. It's almost trivial to understand and implement. It makes no assumptions about the shape of the data. No, everything must be linear. And it handles complex nonlinear patterns for free. As a quick baseline, or when you genuinely don't know the data's shape, it's hard to beat for sheer simplicity. But that stored everything design has a price. To classify one new point, KNN must measure its distance to every single training point every time. With millions of examples, each prediction is expensive and slow. There are clever data structures to speed it up, but fundamentally, KNN does its thinking at the worst possible moment, when you ask it a question. And there's a deeper trap: the curse of dimensionality. As the number of features grows, points spread out until everything is roughly equally far from everything else, and nearest stops meaning much. KNN also demands you scale your features first, or one large numbered feature will dominate the distance. Simple to run, fussy to get right. Still, the core idea, find similar things, is everywhere. It powers basic recommendation systems, spots anomalies as points with no close neighbors, and serves as a fast first benchmark on a new problem. And that compare by similarity instinct returns at massive scale in the vector search behind modern AI. Old idea, long reach. So that's k nearest neighbors, no training, no equation, just store the data and ask the neighbors. It's flexible and intuitive, but slow at scale and shaky in high dimensions. Next time an algorithm that goes the other way, it draws the single best dividing line possible, with the widest margin it can find, support vector machines. See you there.